So this should be easier than multiplying. It's totally different. So this has nothing to do with FOIL and x squareds and stuff like that. This is just honestly glorified combining like terms. I would be lying to you if I said that it always gets answered correctly. Usually what happens is there's a part of this lesson where I'm going to tell you something really important that you should do. And in a perfect world, you would say, I should do that. I agree. And then that doesn't always happen. Some kids are like, challenge accepted. I'm not going to do it that way. And then things happen. And it's the problems. This is still not hard at all. It's just when we do subtraction, I'm just going to give you some advice, and I would, advise that you take it. And that's about all I can say about this. So there's 4 types of problems I'm going to show you real quick. This shouldn't take too long. So it's very simple. So the first thing you're going to see, this also will be on Delta Math today, is you'll see a polynomial. And I'm going to keep using that word, okay? Just be advised, a polynomial is like x squared plus 5, negative 3x plus 4. I mean, just mathy stuff. And again, there's a technical definition of what it is, but don't worry about that. So I'm going to give you a polynomial like this. And I'm going to ask you to add to it another polynomial like this. And this is not like yesterday. Yesterday we had to multiply everybody by everybody. It's a thing. Like, and as some of you demonstrated, you can get really fast at it. Like, it starts to go pretty quick. This has nothing to do with little rainbow Archie connector things and all that stuff. This is just honestly combining like terms. So the first thing you want to take note of is when there's a plus sign in the middle, that's a really big deal. Okay. It's super easy. Like, these parentheses almost serve no purpose. The only purpose they serve in this problem is to identify that this chunk of stuff is being added to this chunk of stuff. But if you think about a plus in front of a set of parentheses, like, what number would come right after that plus? Yeah, there would be a 1 right there, wouldn't there? And if you think about what parentheses, to get rid of parentheses, you have to do something called distribute. And what happens when you distribute a positive 1 to things like this? It just stays. So literally nothing happens. And so when we do addition problems like this, I'm not going to advise that you even show any work. I know that's weird for a math teacher to say, but like, there's no work to show in a case like this. You can honestly just go in and hand pick out the like terms and combine them together. So the first thing that I'm going to identify is that there is an x squared term right here, and that there's another, oh, no, there's not. There's no more x squared terms anywhere, are there? And so in that case, I'm just simply going to, when I go to write my final answer, I'm going to take that x squared term and I'm just going to copy it down. And that will now be a part of my answer. Okay, I'm just going through and picking out things that can go together. And then I'm going to go and I'm going to look and say, okay, here's a negative 4x. And here's another negative 4x. I mean, the first one's like a minus, but it's kind of the same thing. So if you put 2 of those together, what do you get? Right, so I'm just going to insert a minus 8x into my answer. And then the last thing that I see is what are called my constant terms. And there's a positive 5 here and a negative 4 here. And again, just 3rd grade stuff, add those together. What do you get? You get 1. So I'm just, good job saying plus. Thank you. So I'm going to put a +1 in my answer. And that's how easy it is to add 2 polynomials together. Mm-hmm.
Is it the same as yesterday right there? Like, almost positive.
Yeah, like when you add them together. Right. Yeah. So like if you see any terms, so just, I'm going to change something here real quick. This is just to Landon's question. Watch out. The only color I could really use that'll stand out right now is like yellow. Right here, you see where this yellow arrow is pointing? if that had been a plus, then to Landon's point, the two green boxes would now cancel, wouldn't they? You see that? That's always going to be the case in algebra. When you put two terms together, if one of them's a positive and the other one's a negative and they're just like each other, they just go away. Got that? Does that answer your question? All right. So yeah, watch out for that. We're just combining like terms. There's really nothing to it. In the lesson, it can't end there because subtraction is an entirely different animal. And it doesn't really matter. I teach this in so I teach this in ninth grade, and then we use it and talk about it occasionally in other classes as well. But it doesn't really matter how old people are. This next one just gets missed, and it's 100% of the time it gets missed because you know how it is. Like back in October when I told you guys you don't have to show your work anymore. Like if you're going to move a 4x across an equal sign, you don't have to show your work. Just change the sign. But people still miss that, right? This is going to become one of those things if you're not careful. So let's do a subtraction problem so you can just kind of see. It's not hard, but you will be able to see why it's infinitely more easy to screw it up. So let's do a polynomial. Let's do like -5 x squared plus 3x minus 11 and minus another polynomial x squared minus 10x minus 11. So as I always say, advice, take it or leave it. I I don't want you to show work on things when there's no purpose. Okay, but I want you to show work whenever there is a subtraction problem in the middle of one of these. And I have the history to just know in my head, I can tell you when we don't show work on this, we're way more likely to miss it. And I know that again, some people hear that as a challenge, like, well, I'm going to show him that I don't have to. Good job. Like puff out your chest and be happy. I'm really glad. But just the statistical nature of it is that if you don't show it the way I'm about to show you, you are way more likely to do something stupid. And it's not because it's hard, it's just because you're being a goober head. So here it goes. When it's subtraction, that's a big deal. And the reason is because if after that little red minus sign, again, if I put a number there, you agree that there would be a 1, right? And I can't look at this time and say, what happens when I distribute a +1? And, we say nothing happens. This is not like that. What happens when you distribute a -1? Everything changes. Anything that used to be called a minus is now called a plus. Anything that used to be called a negative is now called a positive. Anything that used to be a positive is now a negative. And it's not like we could not do this if we don't show this step. It just guarantees you'll get it right. So here's what we're going to do. If it's a subtraction problem, we're going to rewrite the problem. It takes about 10 seconds. We're going to drop the parentheses. When you drop these first parentheses off, nothing happens because what number is right there in front? Right where I'm pointing with that arrow up top. A positive 1, right? It's an invisible 1. And like we discussed earlier, nothing happens when you distribute a 1. So we can take off the first parentheses free of charge. Just drop them right off. Don't change the thing. But what we want is for those terms to now be out in the open air. Now, when we take off the second set of parentheses, there is a fee that we have to pay. And again, it's the distribution of the negative sign. So when I bring down this x squared, what do I bring down? I bring down a negative. I'll call him a minus x squared. No one ever misses the first one. And the reason is because it's so close proximity wise, like it's next door neighbors to the negative sign. Everyone's like, oh, this is easy. There's more though. You got to keep plowing through, keep going. When you bring down this minus 10x, what do you actually bring down? A plus 10x. And when you bring down this minus 11, I know I get it. It's the whole teenager thing. You're like, what's this guy talking about? This is easy. Just trust me on this one. It really is worth your 10 or 15 seconds to show this step. And now your brain and your eyes and your pencil, everyone comes into harmony and says, I see it. I see all the terms now as they actually are. I can put them together. That is my advice, and I will try not to beat that horse to death. But just know this, if you miss these because you didn't show work, I'm going to have some sassy things to say about it. So recommendation has been issued. Let's put our like terms together. So you don't have to color code them or anything. Like if this were back in August, I might have you like draw circles and stuff. You do what you want. Put your x squareds together, how many you get. X squareds together, how many you get? -6. Because there's already, here, I'll draw some shapes for you. There's already -5 of them right here. And we're going to subtract another one or add another -1, however you like to say that. Those make -6, right? And then I'm going to head across and say, I'm going to put these guys together. There's positive 3x's and positive 10x's. What do we get? Plus 13x. Well done. And then finally, I did this just for you, Landon. There's a -11, bless you, and a +11. What do? They cancel, right? So our final answer in this case would just be -6x squared plus 13x. So we took a trinomial and subtracted from another trinomial and just through happenstance wound up with a binomial. It just happens. I would stop the lesson there, but I'm not going to, just because some of the problems have words in them and I want to make sure that you guys are good. So when you get to your Delta math here in about 7 or 8 minutes, you're going to see some problems that say this. Find the sum of -7x plus 15 and -2x squared plus 4x minus 1. And there will not be parentheses. I clicked through some of these to look for you. And in problems like this, they don't parenthesize the polynomials. So it's your job to identify that, like, this is a polynomial and this is a polynomial. And I guess really the only purpose of this part of the lecture is to say, what does the word sum mean? It means to add. So really this problem is just saying, I want you to add these together. I don't feel personally like this is one where I should have to show my work. Why would I? Like, I know that when I add, there's just no meat on that bone at all, right? So I can just go in right now as the problem's written, do this one in my head, and I can pick out the answers or the pieces that I want to put together. You should always do your terms in order from x squared first, then xc second, and then no xc third. So like it should look like a staircase in your brain. Like highest x goes first, regular x goes second, no x goes third. It's called standard form. So which term piques our interest first? Yeah, I'm going to go cherry pick this one right out. Just place it first and foremost right into my answer, -2x squared. Who goes next? These are called linear terms. And so my -7x, that linear term, and this linear term will go together because they're like terms. How many x's will we have? -3x. So we put it in as a -3x, but I don't mind that you say negative. It's same, right? And then at the end, we're going to combine what are called our constant terms. There's a positive or a plus 15 and a minus or a -1. Say it how you want, add them together. What do you get? Right. So the last type of problem is one that's just it's the end of the lecture, but it's the reason I want to go over this is because it's actually a little bit backwards. So what would you say to me if I asked you to subtract 2 from 10? Right. You can write this down if you want. This part, I just want to talk to you, though, and make sure to convince you of why we're about to do what we're about to do. There's not a single person in this room, I don't think, that would say that the answer to this problem is -8. We all agree. 8, right? We just know. Someone walks up to you and goes, hey, could you do me a favor and subtract 2 from 8? You're like, 8. Or 2 from 10, you're like, that's 8. That's easy. And the reason is because what the human brain does is, even though the numbers in this problem come in the order of 2, then 10, we understand the English well enough to know that to subtract 2 from 10 means to subtract 2 from 10, right? So we're not going to say -8. Yeah, I don't. So the numbers are 2 first and the problem 10. I don't care. I'm going to read it and understand it, right? So having said that, let's do a subtraction word problem, and then I think I'll be done. So let us, you'll see some of these. Let's subtract 3x squared minus 15x minus 10 from x squared minus x minus 14. So the setup is the key. These will take the longest of all of them, just for the record. So you should, out of the ones I've assigned, you'll probably see 5 of these, if I had to guess. playing the odds there. So remember what the human brain does is when we see the word subtract, we're inclined lazily just to think, oh, do this minus this. But what we learned in that last example is that we actually have to do this problem backwards, right? So when I say to subtract red guy from yellow guy, I have to set it up as yellow guy minus red guy. That was the whole point of that last example, was to get you on board to buy it. You agree? Okay, so let's set it up. And I'm going to go ahead and use some parentheses for this one. You might opt to skip this step when you get comfy, but I'm not going to for the lecture, the recording here. So which one goes first? Nice. So x squared minus x minus 14. Then I'm subtracting from him in parentheses 3x squared minus 15x minus 10. The old flip-flopperooski there. And now it's just back to what we learned 7 or 8 minutes ago, 6, 7 minutes ago, I don't know what it was, but the point now is that I have to take this negative sign and give this full respect. There are hundreds and hundreds of kids that have come through my classroom doors before you to prove that that minus deserves your respect. So we're going to take that minus and we're going to distribute it in to clear those parentheses and rewrite the problem. So the first parentheses, remember the yellow ones come off free of charge. We have x squared minus x minus 14. Easy peasy. Now we're going to plow through the second batch, taking off the parentheses. What are we going to do as we go? What are we going to do to all the things on the inside of these parentheses over here? Yeah, switch them. Whatever they were before, they're coming out different. And that can be one of 4 things. Plus becomes minus, minus becomes plus, positive becomes negative, negative becomes positive. Like those are all going to happen. So what comes down in place of 3x squared? Minus 3x squared. And what comes down in place of the minus 15x? Yeah. And then the minus 10 changes to plus. And then at this point, we've now earned the right to combine like terms. So what goes first in my answer? Yeah, do the highest powers of x first. And that in this case is this red guy and this red guy. What do we get when we put them together? Perfect. And then it's time. I'll switch to green here. Let's do green guy and other green guy because they can go together. What do we get? Plus 14x. Beautiful. And then at the end, we'll do yellow and yellow. Put them together. What do you get? Minus 4. That's it. That's how you add and subtract polynomials. You cannot disagree with what I'm about to say. That is easy. I'm not supposed to say that in this line of work because it makes kids feel bad if they don't get it, but I'm sorry. That is easy. So don't make it hard by not following directions. If it's subtraction, give it respect. If it's addition, it's a joke, right? Got it? Any questions? It's on the old Delta math. I realize some of you are still on yesterday's. Here's what I'm going to tell you. I'm saying this into the recording. When I see your happy little face in this room on Monday morning, I am going to assume that you are done with assignment 57 and 58. If you get them both done today, nice. If you don't, you've got Friday, Saturday, Sunday, get them done. I will assume Monday that you're all done. Got it? Okay, cool. So you have find the sum of
Plus 5x plus 8 and 9x minus 7.
okay. So remember when it says sum, that we really like that because that just means that we have to add. And with adding, we really don't have to show any work. So all we're going to do is just remember that like this is one of the polynomials. Yeah, I'm so sorry. I had to turn it off since someone stares at it every time I'm trying to do anything. Sorry, my bad. Thank you. I probably would have carried on like that for another minute. Thanks. So the 2 things in the purple parentheses are the polynomials that we're going to add together. And we don't have to show work because it's addition. So we're just going to go through and hand pick the things we want to go together. Which one would we pick first? Right, so it's just part of my answer is just definitely just 9x squared.
If you drive a dark gray Honda CRV parked in the back empty lot, please come to the office.
So that's that. And then who are we going to go pick out second? Right, so we're just going to put this one together with this one. And since it's addition, we assume, I mean, we know that this is like a plus, right? So there's a positive in front of the 9x. So add those together, what do you get? So, okay, good. Didn't hear that. I was like, uh-oh. And then we got to put these together, the red ones. They're just what we call the constants. What do you get when you add those together? And you're done. That's it. Were you having some issues with that one?
Well, I actually put minus one instead of one.
Yeah, that'll do it. Yep. Anyone else need some assistance? Yep. Is it a word problem or just a straight up subtraction? Okay, so it says subtract something from something, right? So what's your first one? Okay, and it says to subtract negative 4x from 1 plus 1 from something, right? Okay, so it should look like this. Like, sorry, what was the last one? Plus 2. So you have it set up like this? Perfect. So the key again is to show work on these. So I'm going to take off these first parentheses and not change a thing. So I'm going to just take off and just bring down this as is, this as is, this as is. The full issue here is that this minus goes and changes him, and the minus also goes and changes him. We want to let ourselves see that. So what does the first thing pop out as? And then the second thing? Good. So we're just going to go now and put, did you have this on your paper already? Nice. So we're just going to put parts and pieces together. So like this one has no one to go with. So we'll just bring it down, negative 7x squared. And then we're going to put these yellow guys together because they're like terms. How many we get? So plus 8x, right? And then we're going to put the red guys together. What do we get? No. 2 minus 1 is 1. So we have plus 1. The issue here is I just really need you to look at your paper really, really hard right now. Do you follow this purple arrow? Do you have that right there? Okay, so you just dropped the ball on plus 2 minus 1. 2 minus 1 is, of course, not 3. 2 minus 1 is 1. Do you want me to look at your paper? Did you forget to change that to a minus 1? Yeah, and I'm telling you straight up that that is what will happen. If you're going to get these wrong, that's why 100% of the time at the end of that purple arrow is a minus sign. That's the kicker. That's always where these go wrong. So you okay on that? All right. Yeah. Addition, no. Addition gives no what's about order. So no subtraction, order always matters. Addition, it's a free for all.